Today we'll be looking at fuzzing of configurations, notably fuzzing configuration options. What's the idea behind that? Well, very simple. So far, we always have assumed that the input to a program would be some sort of file or something. And this is actually not always the case. There's also inputs that come from maybe unexpected sources. Let's have a look at one of my favorite programs. This is the MyPy static program checker. And you'd assume that the input to MyPy is a program to be checked, which is actually true. But there's more to that. Another interesting input source is configurations. Configurations meaning that there's many ways you can control the behavior of a program. In this case of MyPy, by setting up a configuration file or by passing command line options. And you're going to be surprised how many of the options there are. So, well, whatever, you can disallow any unimported, disallow any expression, disallow untyped decorators, and so on, warn, unreachable. Take your favorite compiler and check out which options it supports. Compilers like GCC have hundreds, literally hundreds of options that all allow you to change the operation of the program in some way. And if you want to thoroughly test a program, or if you want to thoroughly test a program that is as configurable as, well, MyPy, for instance, you need a way to actually test the program with all these different options. There's actually an entire science to how to deal with such arguments. You've seen that there's long arguments which come with a minus and a word, and there's short arguments which come with a single minus and a single letter. And there are actually specialized libraries for processing such arguments. So here I brought along a little program. It's called process numbers, and this process numbers takes a set of arguments, which comes along as a list of strings, and this list of strings then contains individual command line arguments. And in order to parse these, we use a special library, namely the argparse library, which is over here. So let me just define this thing, and let's not forget to also import the appropriate library for that. Import argparse, so you can actually look this up. And what does this do? Argparse takes all the arguments, all the command line arguments of a program, and it has a description, what the program does. And then it describes the individual arguments, and it describes the individual options there are. And it says that, so what we see in here is that process numbers accepts a number of integers, type integer. All of this is being described in here. And it has options, and these options form a so-called mutually exclusive group, so it can only specify one of them. And it also is required. All of these things is something that you can set, and the argparse library automatically checks all this. So you can now put in, and the idea is you have an argument, you have an option which is either minus sum, or minus min, or minus max. What do these options do? What they do is described in this action thing. They store a constant. And where do they store this constant? They store it in the variable named by this field, by this argument destination. So what happens here is that a constant is being stored in the attribute actually accumulate. And what is this constant? The constant is a function, namely sum is being stored here. And for each of these arguments, and for each of these options, as well as the arguments, you can also provide help text that describe how the whole thing is supposed to work. So what does this do? If you provide minus sum, then the constant, what is stored here, which is the function sum, is going to be stored in the attribute accumulate. And what can you do with that? Well, the first thing that happens is you parse all the arguments. There you go. And once you have done that, all the actions that are being specified up here will be applied to your args element, which means that after having parsed all the arguments, you can fetch individual elements of your arguments by checking out the appropriate attributes. And we have said that if you pass minus minus sum, then the function sum is going to be stored in accumulate. So args accumulate would become the sum function, and integers in here is actually the list, is actually the argument, and this is also something that we have specified up here as a string, and this then becomes an attribute of our args object that is being returned. So the arg parser does all of this for you automatically, and it has a couple of extra features too, because it also provides us with extra features such as help. For instance, if we invoke process numbers with the argument minus minus help, then you're actually going to get a description of how you are supposed to use this function, together with the syntax and everything. So here it says minus h, which is a help message. Then it says you provide either minus minus sum, or minus minus min, or minus minus max. And then there is at least one integer that you have to provide, and a number of extra additional integers. You also see the description in here, process some integers, and here's a description of the positional integers. So all of the information that we have placed here for our argument parsers now becomes part of our help text. By the way, if you ever are at a command line and you don't know how to use a particular command, invoking it with minus minus help, or possibly also minus h, is always a good option. And here we also see the other optional arguments. Don't worry about the exception that is being thrown here. If you pass minus minus help, the function automatically exits. And well, we don't want to exit right now, so we catch this. This exception up here, and we can of course now also go and actually invoke process numbers. So what happens if we invoke it just with sum option? Nope. We're going to see we're going to get an error. We need an argument. We need a number. So all this is also handled. So what we actually need to provide here is sum and 2 and 2. Well, that's very simple. And what the function then prints out is indeed the sum of 2 and 2. And for that, and just for the completeness, you can also complete the maximum of one or more numbers. So if you put in 302, then the maximum is going to become 300, and the minimum of the two will become 2. There we go. And you can also invoke all of these with just one number, I think. Yes, this also works. The minimum of 300 is 300. Not very surprising. And if you say something weird, then again you're going to get, oops. You're going to get quite an error message. Very interesting. Woo, 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 woo. I guess don't do it. Invalid int value weird. That's the important thing in here. Okay, and I think we're not going to... Internal Python error in the inspect module. Wow, well that's cool. We discovered an error in Python. See, this is what happens when you do fuzzing. Okay, good. Let's go back to our regular invocation. And all the error messages have disappeared again. Thank you so much. This is really intimidating. I mean, if you give this to beginners in programming, they're never ever going to touch the keyboard again. Okay, so let's go and make this sum while we're at this. Okay, so now if we do have such a program which accepts arguments on the command line. How can we test it? And the answer is very simple. Again, we can use a grammar for that. I can easily come up with a grammar that describes the syntax of the input in here. So this is a grammar which describes the individual arguments. So let us see, what do we have? We have an operator followed by a set of integers. The operator is either minus minus sum or minus minus min or minus minus max. We don't test the help function here. Integers is one integer, optionally followed by more integers. An integer is a sequence of digits, and a digit is anything in the range of 0 to 9. Here we go. And now what we need to do is we need to convert this grammar into a BNF grammar such that we can actually use it for fuzzing. Process numbers EBNF grammar. Long names, I hate you. Okay, here we go. And now we can go and actually use this for fuzzing. Grammar coverage, fuzzer, import. What we need, a grammar coverage fuzzer, obviously. There we go. Grammar cover fuzzer, that's very nice. Duck and cover. Here we go. I'm always happy. And now we can go and create one. Grammar coverage fuzzer of process number grammar, which we have just converted. Let's come up with a few more non-terminals such that we also get some fancy inputs. There we go. And now we have a fuzzer. I thought we had a fuzzer. Process numbers grammar. Okay, get that. Here we go. Now we have a fuzzer, and we can now use this fuzzer to fuzz, and the fuzzer will hopefully, now generate us a couple of arguments in here. So what you have is, we now invoke the whole thing with minus minus min and a couple of numbers. Very simple. And this is of course something that we can also save. Should have saved that before. Here we go. Args. What is args this time? Well, the sum of a couple of numbers. We go and we can split this list again into individual parts. And this is of course something that we can also feed directly into our function process numbers, and thereby obtain the sum of over all these numbers. Nothing too complex in here. Okay, so not very surprising. We can describe the options of a program by creating a grammar over it. And if we have this grammar, then we can also go and generate inputs according to it. Okay, this is all nice. So let me again recall you, however, that this is something that we would have to do for hundreds and hundreds of options. See, here we have minus h, minus v, minus big V, and more options, see below, for MyPy again. And we have all these options: that config file, warn, unused configs, namespace packages, no site packages, Python version, always false, disallow any unimportant, disallow untyped decorators, no implicit optional, no warn, no return, allow redefinition, strict equality, show error context, absolute path, skip version check, warn, incomplete stub, error, exclude pattern, and whatnot. And we would have to type all of these into a grammar. Yeah, sure. Maybe I'll just start typing and you come back and maybe in 2 hours or so. Fortunately for us, there's ways to do this in a much easier way. And this is actually the idea, that we can go and mine such grammars automatically. We have an extra class for that purpose, namely a so-called option grammar miner, and we're going to see the idea of mining grammars, which we already have seen for mining inputs and mining input grammars in our lecture from Rahul Gopinath. We already have seen this, how to do this for general text inputs. And now we're going to look into how to use this for options, and we're going to see even more mining approaches in the next chapters. So I have imported a thing called an option grammar miner, and an option grammar miner actually takes a function that is supposed to make use of the argparse library, so it has to be a Python function. So we're taking process number, so I'm just feeding this in here. There we go. Oops. I was pretty sure it was process number. Is it process numbers? Yeah, process numbers. Thank you so much. Okay, here we go. Now we have a miner. And the neat thing is that we can use this miner to actually automatically extract a grammar that describes the structure of the inputs. Here we go, miner eBNF grammar. And now we have the grammar. Cool, isn't it? Yeah. Sorry, no, it's not cool. I have to show you the grammar. Here we go. Here comes the grammar itself. Boom. And yeah, this of course now is something that you have to interpret first. But what does this thing do? So we have a list, and this list is either empty or it's a set of list objects, and these objects can be ASCII strings. So far so good, not very surprising. And here we have a long definition of what an ASCII string actually is, which is actually not true, because it is supposed to...
You have
why this is
spelled with an E.
Ah! You're so right. Yes. Okay. Ah, now we have it. I was already confused. What do all these ASCII things do in here? And now comes the real fun. So we now have extracted a grammar out of our program, which tells us the exact arguments that it expects. And what we have here is we have a start. Well, that's the start symbol. And the start is first a group element, then possibly a couple of options, of which we can have an arbitrary number. This is an eBNF grammar, followed by arguments. What is the argument? The argument is integers. And integers is just integers, and integers is sequences of digits. More interesting is the group. What does the group mean? Group means we can have either minus sum, minus min, or minus max. And the option can be minus help. And now that we have extracted this, I'll come to how we actually extract this in a second. We can use this grammar again to actually create go and create inputs from that one. So let me see whether I can find this again. Where are we? Here are we. Wonderful grammar. So I have a probabilistic grammar fuzzer. Yeah, that's right. So fuzzer is probabilistic grammar fuzzer of. I think I have to convert this first. Convert eBNF. Is it convert eBNF grammar? I'm not sure. Well, we'll find out in a second. Grammar. So here we go. We have a fuzzer, and if we go now and say fuzzer.fuzz, bing, bong, bong, we automatically get a list of arguments for our functions. In this case, minus max and minus help, minus 9, 887 and minus 37, or we can also do this again and quite a number of help things in here. So now we have something that's going to work well, and we can then again invoke our function with varying options. And since we can invoke it with varying options, we now have multiple. So for a big program, we now have multiple options for creating inputs. Not only do we have the file input that it actually works with, no, we can also influence its configuration as we like. And at least for configurations that are passed on the command line, we can even automatically extract their structure and their arguments. Now, big question. How on earth do we actually get these arguments? How on earth do we actually get this grammar out of our program? And the answer is it's actually pretty simple. We have seen how we can go and trace individual programs. For instance, in when we want to compute coverage. So we set up a tracer, and then we have a function that gets invoked with a function name for every single line of code. And what this option grammar miner here does is it takes this function and executes it up to the point where we have processed all the arguments. More specifically, it takes our function. Let's go back to process numbers in here. I shouldn't have printed out these long names here. Here we go. So what it does, it executes process numbers, and then it checks for method names that are called add argument and add mutually exclusive group, or also the constructor of the parser. And then whenever it sees a function that is called add argument, then it parses the arguments to that function and finds, oh, there's arguments, and the arguments are supposed to be integers. That's how the rule for integers comes to be. Or there's an argument that comes along and supposed to be minus sum, or it's supposed to be minus min. And the other things like the destinations, the miner doesn't care about these, but it knows which arguments are expected. It also knows which groups are being accepted. So it knows which individual options are mutually exclusive. And by tracking all of these parts here, it actually can generate a grammar that represents the entire structure of all inputs. Next interesting question, however, is, so it executes the program. Isn't that risky? Yes, it is. If you say, if you want to extract the arguments from, say, some program that formats your hard drive, and now we are starting this program and then it would go and format your hard drive. That would be quite a side effect, unwanted side effect too. Which is why, and this is pretty neat too. At the moment where this parse args function is invoked, then our tracer throws an exception, and the execution of the program in question is interrupted immediately. And since pretty much all programs first process all their options and their args before doing anything, because they first need to figure out what to do before doing anything, this is a pretty safe mechanism. If we actually go into the definition of a configuration fuzzer, there's quite some material in here which actually does all the checking and everything. So let's wait a moment until this renders. So here we go and apply this option mining on nothing less but the MyPy program, the static type checker for program, with all the options that we've seen before. And what we do here is we run indeed MyPy with an argument here, just so that it has something. And we also enable logging, and then we extract the grammar out of it. And if we enable logging, we see all the individual options as they are being processed with all the arguments and all. So all of this actually goes into, all of this is being processed, so we can learn all the individual arguments there are. And this is quite a number, if I recall it right. Several dozens of individual options. And here finally comes an excerpt from the grammar, namely all the individual options that we have seen. So you can see that we have successfully extracted all the individual options in here. And you can now go and also use this in a fuzzer. In this case, we call it the option fuzzer. And then you can invoke it with all sorts of combinations of individual options in here. And if you thought so far that, say, when you're testing a compiler, that already coming up with all the different variations of input, say, for a compiler is complex, well, you haven't seen all the possible variations also as it comes to options. Tools like big software systems like the Linux kernel, for instance, have literally thousands of options that all influence the compilation and later the execution of the kernel. And yes, we can fuzz them all. That's feasible. We may also be able to check whether fuzzing all of these actually do have any kind of effect. That's also something to look at. But actually ruling out that there is no configuration that causes any particular trouble. Yep, you definitely have a big explosion of possible configurations in here. I mean, sure, if you have n options, you have 2 to the power of n possible configurations to start with. So I'm pretty sure that already with the options of MyPy, you have more ways to invoke MyPy than there are atoms in the universe. And this tells you that even with the best testing and fuzzing tools around, there will still be plenty of configurations that, even though you can generate all these various lists of things just for the fun of it, okay, there will still be configurations which still are untested, which for the optimist, for the pessimist, having plenty of options that are untested is bad news. For developers in particular, because, well, there's still lots and lots of things to do. For the optimist, this is good news. The optimist meaning if you're working as a tester, as a security tester in particular, well, why only pay attention to actual file inputs? You can also go for environments, you can go for command line options, you can go for all sorts of configuration files. You can go for configurations such as hardware configurations, memory configurations, runtime configurations. But you see, there's plenty of space, plenty of ways that we can think about as it comes to input. And all of these inputs can indeed be systematically covered, can be structured. We can extract what their input space is. And, of course, we can have fun fuzzing them. Please go ahead and check out the chapter for how this individual mechanism of tracing through this argument setup actually works. A bit of limitations, of course. The whole thing is limited to the Python argparse library. If your Python program uses some handwritten argument parsing, it's not going to work. It even won't be able to stop the program in time. Fortunately, argparse is pretty much a standard within the Python domain, so okay. You can also try building a similar thing for C programs, for instance. There it is the getOpt function and the getOptLong function, which actually does a similar thing. And yes, then you can have fun, not only fuzzing with plenty of file inputs, but also with plenty of configuration options. And yes, have fun going through this big space and figuring out whether there are configurations where there's trouble ahead. That's all for now. Thank you very much. And as always, I'm happy to hear your feedback. Thank you very much and see you soon.